Okay, now we will be continuing with the topic that we were studying in the previous class. In the previous class, we had learned how to add the decibel values if decibel values of sound pressure levels from various sources are reaching your ears. How will you calculate the total SPL or total sound pressure level that is reaching you? And for that, we have derived this formula. And now in this lecture, after completing another small topic, that is how to average the sound pressure levels or any decibels that are reaching you, how to get an average value. The concept and the mechanism are exactly the same. The only thing is that instead of adding or subtracting, now you are finding the average value. So we start with the concept once again that decibels cannot be directly averaged. जैसे मैं आपसे कहूं, I have got three sources: source 1, source 2, and source 3. And these three sources are sending sound towards a person standing here. Now the sound pressure level LP1 is given for this one. Sound pressure level LP2 is given for this source, and sound pressure level LP3 is given for this source. So the question is, what will be the sound pressure level, or rather the average sound pressure level that you are listening? Now the question is not about the total sound pressure level. Now we are talking about what is the average sound pressure level that is reaching the person. So once again, a person might be tempted to simply take the average like this: LP1 plus LP2 plus LP3 divided by 3 and claim it to be the average value of sound pressure level. But this calculation is not acceptable because the units of all these LP1, LP2, LP3 and LP are in decibels. And decibels can neither be directly added nor subtracted, and therefore they cannot be averaged also. So once again, we claim that if decibels cannot be added or averaged, then I have all the right to average up the intensity. So if source 1 is sending sound waves at an intensity of I1, source 2 is sending out sound waves at an intensity of I2, and so on henceforth till the nth source that is sending sound waves at an intensity of I suffix n, then I can 100% claim that the average of the sound intensities is simply the sum of these individual intensities divided by the number of entries, that is n, or divided by the number of sources, that is n. Intensities can be added, subtracted, or averaged. Now once again, we want to subtly direct our discussion towards the decibel value. So what do? We know that we have to use this expression for intensity. So if I say that I am trying to find some average intensity, so basically I'm saying that I'm trying to find the value of P square upon rho V average value. Okay. I'm trying to find the average value of this entity. And similarly, I can replace each one of this I1, I2 with the same thing. So averaging this, I will get P1 square upon rho V plus P2 square upon rho V plus and so on till Pn square upon rho V and whole divided by n. And since rho V as a denominator is constant, I take the denominator constant for all of these, and rho V on the left hand side and right hand side get cancelled out, and I get this expression: P square average is equal to the average, or 1 upon n times the sum of all the square of pressure values, individual pressure values coming from the various sources. And once again, I apply the same trick. I divide on the left hand side as well as on the right hand side by P reference square. So once again, I want to construct this particular term containing the ratio of P square by P reference square, because then I can eventually lead you to this expression which can be simply added. So once again, since left hand side of this expression is equal to this expression, I can say that whenever I write a term P square upon P reference square, it can be written as 10 raised to power LP upon 10. So since on the left hand side we are talking about the average pressure values, this will be LP average upon 10. And on the right hand side, individual values are there. So in the summation, I simply introduce a counter I and I write LPI by 10 summation 1 upon n. Okay. And therefore, once again applying the law of logarithms, I get this. I take the log on both sides, then this 10 disappears, and then divided by 10 is there. I take it and multiply it here. I get the 10 here. And eventually the average value of LP, I get like this. Now, once again, if you look at this formula, it looks like a very complicated formula to remember. But you do not have to worry about exactly remembering this formula. All that you have to do is remember the way of applying this formula. For example, I will simplify this formula down for you with the help of an example. Let us say I have a source 1, 2, 3. And I am getting sound pressure level LP1 here, sound pressure level LP2 here, and sound pressure level LP3 here. The person who's standing here wants to know what is the average value of sound pressure level that he will be receiving. So all you have to do is write the expression like this. The average value of LP will be equal to 10 log 10. See, this particular part is common all throughout all the formula that we have learned here. 10 log to base 10, and then inside the bracket, you take the average of all the individual LP, sorry, not individual LP values, the expression 10 raised to power LPI upon 10. This is what you have to do. So this is the same formula which was actually claimed to be very complicated. So all you have to do is, since we have three sources, I will claim my LP average to be 10 log 10. This everybody remembers. And then take the average of these expressions, not directly LP1, LP2, but 10 raised to power LP1 by 10 plus 10 raised to power LP2 by 10 plus 10 raised to power LP3 by 10. Added, divided by 3. This becomes the average of such expressions. And when you take the log to base 10 and multiply with 10, you get the average value. This is how you apply the formula for averaging. Now I have already written here, as we discussed in the previous class, that some topics have been left for you to study on your own. So loudness, noise standards and limits, auditory and non-auditory effects of noise, major sources of noise, industrial noise sources, industrial noise control, all these topics have to be studied on your own. Okay. So let us now make use of the formulae that we have learned and try to solve a few numerical problems that generally come in your RTO exams. Now you see, read this question. In a factory, one minute. In a factory, there are 4 machines. When they are all turned off, the SPL of ambient sound is 70 decibel. Okay, so that means although there are 4 machines and when everything is silent, still there is some ambient noise. Ambient noise means noise from the surroundings. See, even if inside a factory the machines are not working, people will be talking with each other. There will be some hum of some other generator that is placed outside the factory, some electricity producing equipment, some DG set, and vehicles will be running outside on the road. So you cannot ever say that ambient sound is zero. And if all the machines are switched off inside a factory, there will be no noise inside the factory. So this question says, when everything is turned off inside a factory, still there is some peripheral sound that is coming inside the factory, and the SPL of that peripheral or ambient sound is 70 decibels. And then individually, the machines produce sound pressure levels of 80 decibel, 76 decibel, 82 decibel, and 79 decibel. So what are these? These are the decibel sound pressure levels produced by the 4 machines that are inside the factory. And let us say that there are only 4 machines. So how do we write it down? Let me just jot it down so that we can take down the data. It is given data that LP1, that is the sound pressure level from first source, is 80 decibels. LP2, that is sound pressure level from the second source, that is 76 decibels. And LP3, 82 decibels. LP4, 79 decibels. I have taken down the data like this. See, so there are 4 machines. I have taken down the SPL levels of each of these machines. And let us see what the question says. Find the total SPL in the factory due to both the ambient sound and the machines. So one thing I have to do, I understand from this question that 4 machines are now simultaneously working and they are producing this many decibels individually. And apart from the sound of machines, there is ambient sound also, which is 70 decibels. So I will take this down also. The ambient sound, let us say the sound pressure level due to ambience, let us call it as LPA. This is 70 decibels. Now, according to the question, we have to find the total sound pressure level. So that simply means we have to add these. All of them have to be added. So by applying this formula that I know, I simply say that the total SPL is simply 10 log to base 10. And how do I add them? I do not add the LP values, but inside the bracket, I will add 10 raised to power LP1 by 10 plus 10 raised to power LP2 by 10 plus 10 raised to power LP3 by 10 plus 10 raised to power LP4 by 10 plus 10 raised to power LP of ambient sound by 10. Now I have covered all the sources. So see, all you have to remember in solving such questions is that addition has to be done for this term 10 raised to power LP by 10. This expression has to be remembered by you. यही एक्सप्रेशन है जिसकी एडिशन सब्ट्रैक्शन और एवरेजिंग होती है. तो कभी भी आपको एवरेज एलपी निकालने को कहे, टोटल एलपी निकालने को कहे, माइनस प्लस कुछ भी करने को कहे, all you have to do is remember add such terms for all the LPs and then take 10 times log of 10. This is what you have to do. Now, if you substitute the values, what is LP1? LP1 is 80. So this thing is 80. LP2 is 76. So this is 76 by 10. LP3 is 82. This is 82 by 10. LP4 is 79. This is 79 by 10. And LP ambient is 70. This is 70 by 10. Just perform this simple calculation on your calculator. 80 by 10, you can even simplify all these things. 80 by 10 will give you 8. 76 by 10 will give you 7.6. 82 by 10 will give you 8.2. 79 by 10 will give you 7.9. And 70 by 10 will give you 7. Now this is just a simple matter of performing the calculation on your calculators. And if, let us see how many people are present. If your answer is correct, you should get 85.88 decibels. This is the correct answer. Now let us try to solve a problem that appeared in your RTO exams, and similar problems keep on appearing in your RTO exam again and again. Now, this is slightly different from what we have done till now. Although the formulae and mechanism are the same, a diesel powered heavy truck has the noise sources with sound pressure level in the presence of background noise as follows. So this is saying that a diesel power truck is composed of these components basically. Okay. So exhaust, fan, engine, air intake. These are the main components of the truck that produce a lot of noise. And the question here, this is a very important part that you have to understand. The noise sources with sound pressure level in the presence of background noise. So basically what these data are indicating are not the pure voice coming from exhaust. So it is saying that the exhaust is making 98 decibels of sound pressure level in the presence of background noise. Background noise means, again, we are talking about the ambient noise. Okay. So that means 98 decibel is not the pure pressure level of exhaust only. Similarly, fan of the heavy power truck is creating 88 decibels of noise when already there is background noise. So that means this 88 decibel contains both the background noise and the noise of the fan. Similarly, this 98 decibels contains both the noise of the background and that of the exhaust. Similarly, engine 83 decibels. That means 83 decibels is the total decibel of the engine noise and the background noise. And air intake 75 decibels. That means 75 decibels is the total of the background noise and the air intake combined. Now the question says, when the truck is turned off, the SPL at the same place is 70 decibel. That means when the truck is turned off, the exhaust is off, fan is off, engine is off, air intake is off. All the individual components have all been turned off. But still you can hear 70 decibel of sound coming from somewhere. So what should this 70 decibel be? This 70 decibel is actually the sound of the ambient noise. Now it is saying, the question is asking you, determine the overall SPL of the truck independent of the background noise. मतलब background noise मिला करके exhaust 98 था, background noise मिला करके fan का 88 था, और इसी तरह से background noise मिला करके engine और air intake का 83 और 75 था. और अगर सारी मशीनों को बंद कर दें, यानी ट्रक को बंद कर दें, तो एम्बियंट नॉइस का अकेले का 70 डेसिबल अपन को सुनाई देता है. तो ये बोल रहा है कि अगर एम्बियंट नॉइस नहीं होती, if ambient noise were not there, then what would have been the total SPL of the truck alone? यानी कि इस एग्जॉस्ट का इंडिपेंडेंट ऑफ एम्बियंट, फैन का इंडिपेंडेंट ऑफ एम्बियंट, engine air intake, all calculated independent of the ambient noise, कितना आता है डेसिबल, उसको कैलकुलेट करके टोटल करना पड़ेगा अपन को. So there are two approaches of solving this question. Both approaches will give you the same answer. I will teach you both the approaches, and whichever approach is more convenient to you, you can remember that approach. Now let me just take down the data here. LP1 plus ambient, this is 98 decibel. LP2 plus ambient is 88 decibel. LP3 plus ambient is 83 decibel. LP4 and ambient is 75 decibels. And LP of ambience alone is 70 decibels. Look at the data now. This is the data that I have taken from the initial given readings. So the first component and the ambient noise combined together produce 98 decibel. Second component and ambient noise combined together produce 88 decibel. Third and ambient combined produce 83 decibels. Fourth and ambient combined produce 75 decibels. And when the engines are turned off, the pure ambient sound has a decibel value of 70 decibels. Now, they are asking you, what is the LP total when LP1, LP2, LP3, LP4 are taken in a combination without the ambient noise. Now see, I have to add up these decibel values without the ambient noise, which I will call them as LP1, LP2, LP3, LP4. Right now, the values that I'm having are LP1 in combination with ambient, LP2 in combination with ambient, and so on. So how do I separate them and then add the remaining parts? For this, the first approach is, I can find my LP1 value independent of the ambient by performing this calculation. I will take 10 log to base 10, and then inside I will take 10 to power LP1 plus ambient minus 10 to power LP of ambient. Now, if I perform this calculation, that is the simple subtraction of sound pressure levels, then I will get the pure sound pressure level of the first component alone. Now I will similarly perform another set of calculations to extract LP2 value. This I can do by taking 10 log 10, and here I will take 10 to power LP of second plus ambient and subtract the value of the LP ambient, 10 to power LP ambient from this. This will give me the LP2 value. Similarly, proceeding on, LP3 can be extracted as 10 log 10, 10 to power LP3 plus ambient minus 10 to power LP of ambient. And LP4 can be extracted as 10 log 10, 10 to power LP4 plus ambient minus 10 to power LP of ambient. Now you see all these values are given to you. LP4 plus ambient is given, LP ambient is given. LP3 plus ambient, LP2 plus ambient, and LP1 plus ambient. All these are given to you. So you simply need to substitute here and you will eventually get the values of LP1, which is the sound pressure level of first component independent of background noise. Similarly, SPL of component 2 alone, SPL of component 3 alone, and SPL of component 4 alone. And now, once you know this, you can calculate the total or the SPL of the truck, let us say, because these components are all inside the truck, right? So SPL of the truck can simply be calculated as 10 log 10, 10 to power LP1 by 10 plus 10 to power LP2 by 10 plus 10 to power LP3 by 10 plus 10 to power LP4 by 10. As simple as that. Once you have isolated these LP1, LP2, LP3, LP4 components, then it is just a matter of adding them as you already have understood how to do that. So this will give you the LP value of truck. Now perform these calculations on your own and try to find out whether you get this answer or not. I will show you the answer. This is the answer that you should get. 98.53 decibels. Okay. Now, let me teach you another method. It's actually not another method. It's the same technique, but using a different logic. Instead of doing the complete calculations in two stages, as I've shown you here, LP1, LP2, LP3, LP4 were individually extracted first by using the subtraction principle, and then the extracted components were then added together using the addition principle to get the eventual value of this. I can directly apply one single shot formula to get the LP of the truck. See, how would I do that? I would say that the sound pressure level of the truck can simply be obtained as 10 log 10 of, first of all, 10 LP1 plus ambient by 10 plus 10 LP2 plus ambient by 10 plus 10 LP3 plus ambient by 10 plus 10 raised to power LP4 plus ambient by 10. But let us refrain from closing the box here. Why? Because if I add these quantities, I already know that in this quantity there is the ambient component. In this quantity also there is an ambient component. In this quantity also there is the same ambient component, and in this quantity also there is the same ambient component. So if instead of extracting the individual components and then adding them, if I add the already given combination components, that means this is already given to me. LP1 plus ambient is already given to me. This is given. LP2 plus ambient, LP3 plus ambient, and LP4 plus ambient are already given to me. So if I directly add them up using this formula, if I simply put it here, instead of extracting anything, I simply put it here. Okay, then I know that each of these terms contains an ambient part, and that ambient part is the same. So all that I have to do is, from the sum of these, I have to subtract 4 times the ambient component. भाई इसमें से एक ambient component निकाल दूं, इसमें से निकालूं, इसमें से निकालूं, इसमें से निकालूं, तो बेसिकली बात तो वही हो गई ना. मैं इनके हर एक में से एक एक करके निकालने की बजाय इनको ऐड करके 4 बार एम्बिएंट कंपोनेंट को एक साथ ही निकाल देता हूं. दिस इज द लॉजिक दैट आई एम गोइंग टू अप्लाई हियर. सो I simply add up the given values despite of the fact that I know that these are not independent values but combinations of ambient disturbance also. And then I go on to subtract 4 times 10 to power LP of ambient by 10. Now this should also do the trick. 4 दफा माइनस कर लिया 4 times. किसको? The ambient component. तो ये जो ambient component जो मैं बता रहा था A, this is the ambient component. So you simply subtract this ambient component 4 times. तो एक ही short formula में आपका direct answer आ जाएगा. So please apply both the techniques. I'm sorry, let me show you the screen. See, I will explain once again because I was displaying some other screen and explaining it over here. LP of the truck can also be calculated by first adding up the components that are given in the problem. Now the difficulty that we were facing was that the components given in the problem were already combinations of ambient sound and the component sound. So it does not matter if you simply add them up. You already know that each of these contains the ambient part. This contains the ambient part. Let me show you once again because I guess you guys missed out on the visual. This contains the ambient part. This also contains the same ambient part. This also contains the ambient part, and this also contains the ambient part. Now, if I want to subtract or remove the ambient part from these combo components, I have to identify what is this ambient part. This ambient part is basically 10 raised to power LP ambient upon 10. This is the ambient part which I can directly subtract, add, or use in averaging. And since there are 4 ambient parts that I want to remove from this sum, all that I have to do is I simply go ahead and make use of this calculation. From the sum of these components, I subtract 4 times the ambient part, that is LPA upon 10. This is all that I have to do. So in one single formula, I will be directly able to get the SPL of the entire truck independent of the ambient sound. So whether you go with this single formula or you decide to individually extract the LP1, LP2, LP3, 4, and then you decide to add these extracted components, they will give you the same answer. So please check it out whether you are getting the same answer or not. The answer should be 98.53 decibels. These are important questions. They are always asked in your exams. So you have to take care that these questions being very simple, it is much more logical to prepare such questions in advance so that if it comes in the exam, you can attempt these questions head on. Now, as I've already told you, these parts, I am going to give you some additional support material, but the preparation has to be done on your own. And we have completed this part now. This part is over. Again, there are two topics that remain here. I will send separate notes for these two topics. And let me show you one more thing. I have made a small collection of questions that have appeared in your RTO exams over the past few years. So you can say I have made a survey from the year 2010. 2010, these were the questions that were asked. See, what is inverse square law? Inverse square law is basically the law that with the distance, the sound intensity reduces. How does it reduce? Inverse square law. Inverse square law for sound. We are talking about inverse square law for sound. What is that? It says that intensity of sound is equal to sound power or watts divided by the spherical surface area. Now this spherical surface area is 4 pi r square. So basically I can say that intensity of sound is W upon 4 pi r square. And if I say that I have a source of sound and it is emitting sound in all directions in the form of a spherical envelope, and if I assume this sound power to be a constant, I get that the intensity of sound at any location is inversely proportional to the distance from the source. This is called as the inverse square law. So this is nothing special. This is something that you already know. The only thing is that somebody is asking you using a fancy term कि भाई इनवर्स स्क्वायर लॉ क्या है. देखते ही आदमी घबरा जाए, पता नहीं यार ये क्या चीज है, मैं तो पढ़ाया ही नहीं है. Everything has been taught to you. You just should know how to write your own explanation for things you have understood. And now look at these questions. Write a detailed note on subjective response to humans, subjective response of humans to sound, explaining frequency dependent and sound pressure dependent human response. ये सारी चीजें हैं. So I will be providing you with a copy of these notes. This directly contain all the things that you need to understand. ठीक है, तो ये इसमें कुछ ऐसे पार्ट्स हैं जिसमें मैंने क्रॉस लगा दिया है रेड इंक से. So you do not have to study those parts from these set of notes that have been crossed out. ठीक है, आपको सिर्फ ये जो एडिशनल कंटेंट मैंने आपको सेल्फ स्टडी के लिए दिया, कौन कौन सा है ये देखिए. ये जो एडिशनल कंटेंट आपका सेल्फ स्टडी का पार्ट है, इसका सबसे सिंपलेस्ट वे है ये जो नोट मैं आपको भेजूंगा, इसमें से ये क्रॉस्ड आउट पार्ट को छोड़ करके इट इज नॉट मच फॉर यू टू लर्न नाउ. ठीक है, पूरा थियोरेटिकल कॉन्सेप्चुअल बेस्ड चीजें हैं इसमें, और बाकी की वो चीजें भी ऑलरेडी हैं जो मैंने यहाँ पर आपको क्लास में पढ़ा दिया है. सो यू कैन सी देयर आर 32 पेजेस फ्रॉम दिस नोट्स, but all 32 page is not fresh material. I have already taught you more than half of it. So if you skip that and skip the part that I've crossed out, skip all the numerical problems also, because that we have discussed here, तो जो बचता है जैसे कि ये आ गया, जैसे look, human response to sound, very briefly and beautifully things are given here, so you don't have to overexert yourself by studying extra material. ठीक है, see, auditory effects of sound, non-auditory effects of sound, these are all exactly given in your syllabus. See, auditory and non-auditory effects of noise, everything given in order. So all you have to do is simply study this document of 32 pages that will help you to cover all this part of syllabus that I have not taught to you. Or see, industrial sources and control, everything is given in a short note format here, very beautifully given. You don't have to refer any other place. But again, this particular note has got a problem that it is a little bit concise. So things are stated as a matter of fact, and there might be some areas where you might get a question in your mind कि भाई ऐसा क्यों. तो इसका बहुत ज्यादा डिटेल्ड जवाब, सब सवाल जवाब इसमें नहीं मिलेगा. इसको जैसे आपको एग्जाम में लिखना होता है शॉर्ट नोट्स की तरह ही इसको प्रिपेयर किया गया है. In order to learn in depth, if somebody is interested in understanding the concepts in detail, कि नहीं भाई हम तो पूरा अच्छी तरह से इसको समझना चाहते हैं, we want to actually understand it, then I will send you additional content for that also. But for that you will have to do a little bit more of reading, and that would contain nearly 100 to 150 pages. So you should be ready for that if you want to learn in detail. Otherwise, if you just want to prepare for your examinations, if you just want to get the stuff as it is without any much explanation, you want to get the stuff exactly as you have to write in your exam, then this note that I will be sending you should be more than sufficient. Okay. And as I was pointing out, let us go through the RTU question paper 2011. Now see, decibel scale, addition, subtraction, you know. Frequency dependent human response to sound, you will get from the notes. Sometimes these questions creep on very frequently. Octave band analysis. This is not mentioned in your syllabus. See, you will not be able to find octave band analysis anywhere in this mentioned syllabus. But somehow, somewhere it becomes a part of some of this stuff. ये जो यहाँ लिखी हुई चीजें हैं उसके अंदर कहीं ना कहीं किसी चीज से वो रिलेट होती है, इसीलिए आरटीयू वालों ने वो कई बार पूछा हुआ है. एंड वंस इट स्टार्टेड अपियरिंग इन योर एग्जाम्स, देन इट इज कमिंग अगेन एंड अगेन. सी, ऑक्टेव बैंड एनालिसिस आ गया, ऑडिटरी ये सब आता है आपको, नॉइस कंट्रोल, ये सब चीजें आपको नोट्स में मिल जाएगी. नाउ लेट अस गो ऑन एंड सी. Sound pressure, frequency dependent, everything is the same. Auditory, non-auditory, industrial noise sources, you can easily do. See, sound spectra. Sound spectrum क्या होता है? Octave band analysis. Again it is coming, and this is from 2014 paper. ज़्यादा पुराना भी नहीं है. तो ये कई बार आ चुका है ये. Octave bands, sound spectrum. What is this? ठीक है. तो इसीलिए एक तरह से ना चाहते हुए भी हम ये कह सकते हैं कि ये साउंड स्पेक्ट्रम और ऑक्टेव बैंड एनालिसिस आपके सिलेबस का पार्ट है, क्योंकि ये बार बार आरटीयू में आ रहा है, तो आपके इस बार भी आ सकता है. तो अभी क्या करने का है? वी डोंट हैव एनी अदर वे बट टू स्टडी साउंड स्पेक्ट्रा एंड ऑक्टेव बैंड एनालिसिस. लेकिन इसको मैंने, अगर आप किताबों से पढ़ने जाएं और इफ यू गो एंड स्टडी इट फ्रॉम द इंटरनेट, तो you will find it really tiring, and there is a very good possibility you will not understand it. So I have compiled a short 5-page note for this also. Sound spectrum and octave band analysis के ऊपर एक छोटा सा मैंने compilation किया है. But we will not be starting this today. इसके लिए मैं एक अलग से आपको, या तो अपना ऐसा कोई कॉन्सेप्ट बने कि आपके सेकंड मिड टर्म के बाद भी क्लासेस अगर कंटिन्यू होती हैं, अगर क्लासेस कॉलेज चलाता है, तो अपन ये सारे जो बचे हुए टॉपिक्स हैं, ये साउंड स्पेक्ट्रा हो गया, ऑक्टेव बैंड एनालिसिस हो गया, और द अदर थिंग्स दैट वी हैव लेफ्ट आउट नीचे, वाइब्रेशंस ऑफ गियर्ड सिस्टम, जनरलाइज्ड कोऑर्डिनेट्स एंड कोऑर्डिनेट कपलिंग, ये सारे टॉपिक्स लाइव क्लासेस में कवर करेंगे. एंड इफ नॉट, then I will give you recorded lectures for these topics as well as for sound spectra and octave band analysis. वो क्या चीज होती है, ये आपको थोड़ा सा समझ में आ जाए तो आप अपनी वर्ड्स में खुद एक्सप्रेस कर पाएंगे. आपके लिए नोट्स तो ऑलरेडी तैयार रखे हुए हैं मैंने यहाँ पे. साउंड स्पेक्ट्रम किसको कहते हैं, ऑक्टेव बैंड एनालिसिस क्या है, these things are not very difficult. एक बार आप इसको मेरे साथ में समझ लोगे, उसके बाद आपको अपने वर्ड्स में एक्सप्रेस करने में भी कोई दिक्कत नहीं आएगी. ठीक है. नाउ योर एग्जाम्स आर अप्रोचिंग. आज की तारीख में जो जो न्यूमेरिकल्स मैंने आपको सॉल्व करवाए, उस टाइप के न्यूमेरिकल्स आपके एग्जाम्स में इंटरनल में भी आएंगे, एक्सटर्नल में भी आएंगे, पक्की बात है. So please make a good preparation of these because these numericals are not difficult, they are easy. और अभी कैसे है हिमांशु कुशवाहा, सुन रहे बेटे आप? Okay, then I'll stop the discussion here.